Friends, we would start with our next session, which is value creation through analytics, cognitive analytics is the topic, for which we have our speaker who is Deepak Desai, Deepak Desai. He is an executive director and partner with IBM Analytics Asia Pacific. He heads the Asia Pacific team for analytics. He has worked in various roles in IBM for more than 20 years. He's a cost and management accountant and has extensive experience in manufacturing, automotive, and industrial sector. He has worked on various cognitive and IoT solutions in manufacturing sector. Currently, he's focusing on IBM Watson and development of IBM Watson in manufacturing sector. I would request our past president Shirish Deshpande and Vijay Bhale Rao to felicitate the guest. Come on, sir. I request Deepak to take over the session.
Wait for me, girl, wait for me. Wait for me, girl, wait for me. Wait for me, world, wait for me. Wait for me, world, wait for me. Wait for me. Keep up till the sun goes down. Don't chase that moon till the blood come out. Wait for me, butterfly, wait for me. I'm only trying to set you free. Wait for me, problems, wait for me. I'm only human, so let me be. Let me be. Keep up till the sun goes down. Don't chase that moon till the blood come out. Gotta keep up till the sun goes down. Don't chase that.
Good afternoon, everyone. I just thought, actually wanted to do some exercise, but then I thought this was better than the exercise. So this is the new IBM, and this is the new technology. We no longer are making any of the servers. We no longer are into what we used to call ourselves as, or we used to take pride saying that we used to build software. What we do today actually is, we are in the fashion industry. So today, Watson computer can predict what is going to be the fashion that is going to come probably 1 or 2 years down the line. Just to kind of to give you a feeling, there are some 5 or 7 fashion shows that happen in the world today which determine what is going to be the trend for the thread which is going to be manufactured 2 years down the line. So this is what it is. Let's say if denim was out of fashion, you and me know today that denim is out of fashion, but the industry was knowing this 2 years before. And now I don't know whether the industry made sure it went out of fashion or it really went out of fashion. So that's what we are doing. So we are into medicine now, we are into research, we are into clinical trials. We are actually, quote unquote, trying to replace human intelligence. So that's what we will talk today about. So all of us know today that there are various sensors that are being used in our day-to-day life. You have these Fitbits that are coming up, your mobile phones are having lots of sensors. You get into manufacturing organization, you'll have sensors all around. You have home automations that are coming up. You will see the public utility transport facilities also using various kinds of sensors. So there is huge amount of data that is getting created. And unfortunately, in spite of having so much of data, there is no clarity in terms of what is it that we want to do with this data. And to add to this, then there is what we call as unstructured data. So all this while, when we said data analytics, when we talked of information warehouse, when we talked of data warehouse, the requirement was your information has to be structured. It has to be in tables, it has to be in fixed format, it has to be in a particular way, then the system will come up and do all sorts of analysis. Suddenly there is a need that has come that there is a lot of unstructured information that is available. How do I take care of that? And unstructured information is not only in the form of text, letters, mails, it is also in terms of emotions, people talking to each other, telephone calls, video messages, video calls. So this is where the information is lying today. What we are trying to do is there any way I can go into these set of unstructured information, come back and say that, okay, fine, I've got this set of information and it's making some sense here. How is it affecting my business problem? So that is what we are going to look at it today. If you ask me, this is where all of us are today. There's a storm there. Nobody knows what's happening. There's a huge amount of information that is available. We don't know what to do with it. And this is where we actually need a machine to go through the entire, the whole amount of information that is there and make sense out of it. And now, think about it. There was a time when a computer used to, as I said, it used to understand certain tables, structured information. Now I'm making the computer not only understand the structured but unstructured information. It should be able to understand language, it should be able to understand my emotions, it should be able to understand my feelings before it kind of takes a call saying, okay, fine, you're right. So what I'll also cover today is, going forward, you will not see a computer or a person sitting in front of you. You will see a machine which is probably a robo, or you will see a machine which is actually talking or chatting to you over your Windows screen or your laptop screen. It's actually not a person who is chatting on the other side. That's what is going to happen today. If I go back to the industry, how have they done? Unfortunately, we have not yet reached the peak. There are some industries which have been on the forefront, more to do with the manufacturing of the industrial organization. That too because of the manufacturing, the way it was being manufactured. So we'll talk of what is Industry Revolution 4.0, or how industry has revolutionized, that has helped. Consumer product industry has, yes, to some extent it is there. Government, for various reasons, it's not there. But unfortunately, the retail is still picking up. What we see today of retail is something very, very nascent, I would say. There is a lot that needs to be done today in retail, and that's where most of this image analytics is going to come into the picture. I don't see long where I'll just go to a place, take a picture of, let's say, a particular kind of shirt or a dress, and I'm able to go and shop based on the image that I have selected, not on the text. So just imagine, I select an image and then it goes back into the system and says, okay, this dress is available or this shirt is available in these places. Now, to add to it a cognitive power which says, if you want to match this dress for a formal occasion, what is the kind of dressing you should be doing overall is what the system will come up and say. So this is what the future of retail is going to look like. So if I go back again in terms of where the industry is today, there is immense opportunity. There is immense opportunity in terms of what is going to happen from now till 2025. If you talk of companies like the automotive manufacturers, if I have to take Indian companies here, Tata Motors or the Toyotas of the world, or Mercedes or the BMWs of the world, their fear today is not that the competitor sitting next door, who is also manufacturing car, will come up with a better car. Their fear today is a Google sitting there, who is talking of getting a car on the road without a driver. And it's so difficult. See, these organizations have technically or in their DNA have grown, making sure one of them, let's say a particular car manufacturer is good at providing cars which have got good facilities. American cars, always nice, luxurious from inside. German cars, always good at performance. The engineering is perfectly fine. You will not get the luxury you might get in an American car, but definitely from performance-wise, it will be much, much better. Now, suddenly, they have to say that I don't have to look at the way I'm manufacturing a car or the way I'm selling a car, because somebody else is talking of completely different, a Google, a Tesla. In fact, there is IBM Watson actually also drives Ollie. It's a bus which kind of goes into a campus. It's a driverless bus. And this Watson starts talking to commuters as they get into the bus. So it's not only a driverless bus, it starts talking to you. I mean, just imagine you're getting into it and you're having a conversation in terms of what's going on and things like that. You would have seen the advertisement of Google where, it kind of take all sorts of instructions when you're at home. So this is what is going to happen probably down the line. I mean, it's not far. Years, 2 years, 3 years, down the line, this is what is going to happen. From a technology perspective, was it not there earlier? No, it was there. The only problem was the compute was very difficult. The compute power was very difficult. We didn't have machines which can take that kind of intelligence, which can take that kind of algorithms. Today, a mobile phone probably is much more capable and powerful than what the computers that we used to have probably 25 years back. So if you ask me, this is the same technology which we used and helped the Americans go to the moon, go to the Mars. That's available today at our disposal. That's what is happening to technology today. And this is what we call, if you go back to the late 70s, late 80s, or early 90s, where Kodak actually was the biggest paper supplier to the photo industry. More than 90% of the pictures which were printed were on Kodak. Late 90s, Kodak was nowhere because of digital cameras. But digital cameras were there in 75, 78, 80s also. The exponential growth in technology led to fall of Kodak. And this is what is the fear of all the manufacturers today. They are not fearing that somebody who is manufacturing next door will compete with me. They are fearing that somebody who is nowhere today and is doing something is going to probably capture the market. You have got examples like Airbnb. No, they don't own any real estate, but they are the biggest provider of hotel space. You have Ubers of the world. These are the ones who are going to take, the challenge that the entire industry, automotive industry is facing today is just imagine if you are able to book a Uber the way you're booking auto rickshaw in Pune. Why would you own a car? Right? So this is the biggest fear the automotive industry is going to have. And this is what is going to happen to every industry today. It's not only the automotive, but every industry is going to go through some or the other change. So what happened to the manufacturing sector? If I go back to the industrial revolution, we started manufacturing, then we went into machines. We had the biggest revolution, which was the conveyor belt which came up. Then we had all the machines which are being automated. Now the stage has come where the machines are talking to each other. And machines are learning on their own. So there was a time when programming was done. A plus B is equal to C was taught to the computer. So you do it, whatever it is, it will come to A plus B is equal to C. But it was not knowing if it was A plus B plus C is what, it was an error. Today the technology is changing. Today nobody is programming the computer. The computer is learning. Watson, actually the artificial intelligence that we call, is not something which will come and say, okay, this is the computer, let's start do programming. No, this is the computer, you give me data, it will learn. The more and more data it has, the more and more information that it will gather and it will be able to take a decision. If I go back to oncology today, if you are aware, an oncology expert, before treating or giving any medication to his patient, he has to go through some n amount of literature to understand the disease. Humanly, it is it's impossible for anybody to make sure he's updated with the latest information, what's happening in the market, how many cases were there, what went wrong, what is there. It's not possible. So it was all depending on, let's say, how many patients I have seen, what is my skill, how much time I have spent in studying. That's what will show up. But Watson today actually does the same thing. If a report is given to Watson, it will tell you what is the kind of treatment that is to be given. And that is based on research and treatment that is happening worldwide. And that's happening in India, in Manipal Hospital. That's the situation today. So if you, it's again, it's the same thing. So it's not something which is If it comes up with a new case which it doesn't know, it has to go and do the research like a doctor does. So it goes through its entire database and tries to find out from structured, unstructured information what has happened. And it comes back and says that I have got 20% confidence because it's a new case. I've got 20% confidence in what I'm predicting. The reason being my database is not strong. So if I want to increase my probability, I need to provide more data. So that 20%, so just imagine somebody saying that, the data that you have given me is 20% good. That is the kind of analytics which we are doing today. The good old days, it was more like, I had lots of fancy graphs and bubbles and pictures showing which says, oh, this is good. But then if the data was crap, it was crap. But here the system itself will going to tell you that this is what is going to, what you're showing is not actually the right thing because your confidence levels are very, very low. So from an industry perspective, if I have to get into what we call as Industry 4.0. Now Industry 4.0 was a term which was coined in Germany as part of the Industrial Revolution. What it means is basically, how can machines start talking to each other and start taking decisions rather than a human being getting into the picture. So now the whole thing, if you go back today in all the supply chain problems, this is what is the target. I mean, people don't want to get into a human intervention in taking the decision. Can I have the system learn on its own? So if we have to do this, then we definitely have to make sure the machines have to be connected. A good thing or a new thing which is coming up, what we call as the API economy. You no longer are restricting yourself saying that, okay, this is my set of people. They are going to work on a set of transactions or they are going to work on a set of systems and that's how it's going to work. Today, there are a set of people who are working, developing APIs which can solve your business problem. I just I have to go and take the service of those APIs. It's like, somebody developing a program for you. You just go there and say that, okay, I'll use your program, but not every day because I need to, let's say, look at the weather data once in a month when I have to do the forecast. And once I know the weather, how the weather is going to perform, I'll decide on how I need to manufacture, what I need to manufacture. That's how it's going to happen. I mean, if you go to US, when Walmarts and Cokes were being put in the store, the responsibility was of Coke to make sure they ensure that the entire stack of Coke products were available on the stack, right? If something is moving really fast, information was going back to the factory saying that, okay, why, you just have to go and start pushing back your product. And if that's something which is going really fast, then the manufacturing team should come to know that I need to change the plans, right? Because I need to start manufacturing what is getting sold in the market. So that's the technology that we are talking about. From an IBM perspective, so what we did is we realized that we have to be an open platform. We cannot come saying that, okay, this is what is our platform, you have to be compatible, this, that, blah, blah, blah. So we said nothing doing. So if you saw in the video, it clearly said we were going open source. So we came up with something called an Watson IoT platform. Now this platform has pre-built or inbuilt connectors. So today I don't have to worry, 90 to 95% of various device manufacturers, protocols that are available in the market can be directly integrated into the Watson IoT platform. This is the biggest part of it. The reason is things are going to change, things are going to improve. So I don't have to go back and say that, okay, fine, now I need to change my platform because 3 years have gone, 5 years have gone, technology has changed, things have changed. No, so you don't have to do that. We have also doing is you don't have to buy the entire software. It is available on cloud, it is available as a service. Software is available as a service to you. Use it as much as you want. If you don't, even if I just want to try it once, I'll go and try it and come back. If I like, I'll use it. If I don't like, I'll not be using it. I mean, we ourselves are transforming. We ourselves are undergoing a change where we have realized or we know that we cannot go into the market saying that this is the software that you want to buy, this is the hardware that has to go with the software, and this is this 1 year or 2 years of implementation period. That's no longer going to be the case. So we go to the customer saying, okay, I have a problem, can you solve it in the next 2 days? So what we have done is we have built in industry platforms. So rather than, so what we did is we actually took the problems that are there in the industry, kind of tried to collate that and said that, okay, fine, can I put some logic behind this and try and solve some of the problems which has to be, maybe it is your supply chain related problem, a network optimization problem, or basically supply chain logistics problem. These are the things which we have started building in. Cognitive journey, basically, there was a time where we were saying we need to be, we should have systems in place, we should have data in place so that we can start looking at analytics. That was actually the foundation. The next stage now is going to be cognitive. How can I take my data and start building references? There are manufacturing organizations, for example, there's a tire manufacturer. The quality of the tire is not only dependent on the material, the raw material that gets into the tire, but the manufacturing process which has the temperature. So the ambience temperature that you maintain in the manufacturing process, the temperature that is controlled when it moves from one process to other process decides the viscosity, as they call it, of the tire or of the rubber. And if by the time you're going to pour the rubber in the mold, and then you realize the viscosity is not good, you have lost. I mean, what the product is going to come out is bad. So today there are analysis that are going on, not in capturing the parameters of the raw material, but the parameters of the ambience. What is the ambience temperature? How is the flow happening? Can I control the flow so that my output, which is the viscosity, is high? So my product that comes out is high. So the industry is going towards more in terms of how can I use references, relationships to determine what